Now we're looking at perpendicular lines, and it says line H, which is this blue line, passes through 3, 0, and 7, 6. We want to graph a line that's perpendicular to H that passes through 2, 5. So we've got a point out here, and actually it's already given us the answer. The red line is the answer, but we're going to go over how to do this step by step. So the first thing I need to do is find out the slope of line H. So I'm going to do slope of H, and I look at this and I say, okay, the y's are 6 and 0, and the x's are 7 and 3. So if I do that, on top I have 6, on the bottom I have 4, reduce, this is 3 over 2. Now, in order for lines to be perpendicular, the two lines are opposite reciprocals of each other. So for example, the slope of this line is 3/2. So if I want a perpendicular slope, what I need to do is flip this and then change the sign of it. So flipping it makes it 2/3, and changing the sign makes it a negative 2/3. If this was already negative, then we would change it to positive here. But since it's positive, we change it to negative, we get a negative 2/3 here. Then what we do is we say this point has to be on the line, so the slope tells me to go down 2 to the right 3. So I go down 2 to the right 3, I put another point here, and I can graph my line. And that's it. That's all you have to do. Again, find the slope of the original line, find the perpendicular slope, then take this point, and that tells me go down 2 to the right 3. So I go down 2 to the right 3, put another point, and I'm done. Show you what they said to do as well. So again, find the slope of H, just like that. Then they explain that the product of two perpendicular lines is -1. That's just a fancy way of saying that they're opposite reciprocals. So what we can do is we can say 3/2 times the measure of angle 2 equals -1. And so if we flip it, basically if we multiply by the reciprocal on both sides, we'll end up with the opposite reciprocal, which is just what I told you it would be. And now that we know that, all we have to do is graph the rise and the run. So again, like I said, whoops, let's do this way. Whoops. Like I said before, you'd basically pick this point, since that point has to be on the line, and then use the slope to find the second point. Okay. For this next one, we have to interpret what this graph is saying. So if we look at it carefully, we have a skydiver making 3 jumps with 3 different parachutes, and it shows the height on the y-axis. So here it's about, what, 3,500, and up here it's about 4,500, it looks like. And then this tells us the time in minutes to land. So here it looks like almost 4 minutes, and here it's about, what, 5 minutes, a little over 5 minutes. So we want to know which statement here is true. It says parachute opened at the same height in jumps A and B. Well, jump A opened here and jump B opened here, so that's not true. Then we look, the parachute was open for the same amount of time in jumps B and C. Well, here's the time for B, here's the time for C. So that's not true either, so neither of those are true. Next thing we look, it says the skydiver descended at the same rate in jumps A and B. Well, if that was true, remember rate is distance over time, so that would mean that this slope for this line would have to be the same as the slope for B. And if you look, it looks like they were at a higher height for B and landed at the same time, so B had to have been going faster than A. And if you look, the slope is steeper, so therefore the same rate isn't done for both. But for A and C, if we look, A and C look like they're parallel, therefore the answer is D here. So be careful there. Make sure you understand what happened. Rewind if you need to. Again, The rate at which the skydiver descended is represented by the slope, and the segments have the same slope for A and C, so the answer is D. For this next one, similar to the last one, but this time we're given two lines and we want to know if they're perpendicular. We're going to find the slope of n, and again we take the y's, so we do 5 minus 2, and the x's gives us 6 minus 0. So on top we have 3, on the bottom we have 6. Reduce, this is 1/2. I'm going to write down here what I want my perpendicular slope to be. I want to flip this and change the sign, so it should be -2/1 or -2. Let's hope that it's this. If it isn't, then the lines are not perpendicular. For these next examples, we're going to look at parallel lines. Give me one sec here. The thing you need to remember with parallel lines is, alright, sorry, double speak there. So now we're going to look at line M and see if that's perpendicular. Or I'm sorry, see what the slope is for this one. So now we look and we see the y's, we have 0 and 4, so 0 minus 4. For the x's we have 4 and 2, so we say 4 minus 2. And we have a -4 on top, we have a 2 on the bottom, so if you look, reducing that we get -2. And if we want to explain, we would say, let's see, perpendicular slope. So we would say, first of all, n is perpendicular to M. And the reason would be because perpendicular slopes perpendicular lines, sorry about that, lines have opposite, not negative, but opposite reciprocal slopes. Okay? So again, looking at this, the product of the slopes is -1, or you can say they're opposite reciprocal slopes. For this one, it says which parachute is in the air for the longest amount of time. Well, A and B were in the air for a little under 4 minutes. C was in the air for over 5 minutes, so it would be parachute C. And finally, looking at this picture again, it says what do the x-intercepts represent? X-intercepts represent the time in minutes. So how do we use that to eliminate at least one of the choices? We can actually eliminate both choices because A and B land at the same amount of time and C lands at a more time. So the time of the landing is what X stands for, and B and C are different. Also A and C are different, but B and C are different, which was what we were worried about. And that's it. Thanks.